Hello, welcome to this video. Today we're going to look at this number theory problem. So the question is as follows. The problem is as follows. We need to find all pairs A and B, which are whole numbers, that satisfy A cubed plus B cubed is 91. And first, when you look at this, you might try to maybe move things around, try to sort out things with cube numbers, maybe split 91 to cube numbers. I don't know, but and then maybe try to divide it like that. But you always need to remember, in these types of problems, you're looking for a way to factor. You're looking for a way to factor. And when you're factoring, you're looking for a way to factor. And you cannot forget the factorization of sums of cubes, because you can't factor A cubed plus B cubed. So, write out the way, that's immediately what we're going to do. So, if you don't remember A cubed plus B cubed, you can split this up as follows. You have A plus B multiplied by A squared minus AB plus B squared. And you can also, if you want to completely convince yourself, you can factor this out and show it's the same as A cubed plus B cubed. But now we can say this is equal to 91. And now here, because A and B are whole numbers, we know A plus B and A squared minus AB plus B squared are whole numbers, because all we're doing is summing and multiplying them. It doesn't change it. So these both of them are whole numbers. And another key thing to note here, that'll also help when we factor 91, is to see that A squared minus AB plus B squared is always positive. And a nice way to see why it's true is to look at it this way. A squared minus AB plus B squared, you can say this is a fourth. And you will see why we're taking a 4 out. 4A squared minus 4AB plus 4B squared. And this is 1/4 of, now I'm going to split this up as 2A as, so I'm going to write it as follows. So we have 2A squared minus 2 times 2A times B plus B squared plus another 3B squared. And just look at it, you can easily convince yourself that it's true. And now we can now write it like this. This is 1/4 of 2A minus B all squared plus 3B squared. Now 2A minus B squared and B squared are both bigger than or equal to 0, because they're just whole numbers being squared. When you add a plus 3 times B squared, that still doesn't change it. So we get a 1/4 of something non-negative, That's our expression, meaning that our expression is itself non-negative. So that's a quick way to see why that's true. Why a squared minus ab plus b squared. Why it is positive. And now we're going to have a much easier time splitting this up. So it's going to be much easier when we factor 91 out. So 91 can be represented as a product of two numbers when one of them is non-negative in 4 ways. So this is 1 times 91 and 7 times 13 and 13 times 7 and 91 times 1. You may be wondering why I just switched the order here, but I did that so we'll have the different cases for a plus b and a squared minus ab plus b squared. Just because a plus b is equal to 1 and a squared minus ab plus b squared is 91, just because that case exists doesn't mean we just completely forget the other case when they're switched around. So now we have these 4 cases, and now we'll just have to solve for each one of them. So what I'm going to do, instead of doing one case at a time, I'm going to do them all generally, like so. So I'm going to say a plus b is equal to x, and a squared minus ab plus b squared is equal to y. And I'm going to find an equation for a using x and y, and then I'm going to look on each case and see which one of them makes an equation that we're able to solve. So here's what we're going to do. This is just algebraic techniques. What we're going to do is square a plus b. So from here we get a squared plus 2ab plus b squared is equal to x squared. But now, this is also equal to y if we replace the negative ab with 2ab. So we can say that this is y plus 3ab. And now we can solve for ab, and we get that ab is equal to x squared minus y over 3. Now we will isolate b and then substitute it in our first equation. So b is equal to x squared minus y over 3a. Substituting that in, which we'll write over here in the first equation, we get a plus x squared minus y over 3a is equal to x. And now, very simply, we'll just multiply by 3a and then move x to the other side to get the equation 3a squared minus 3ax plus x squared minus y is equal to 0. Now, we know there is a solution to this equation. Maybe not a solution with whole numbers, but still a solution if the discriminant is bigger than or equal to 0. With the discriminant being delta b squared minus 4ac. And so, we know there is a solution for a. Maybe not a whole number, but still a solution if if our discriminant, which is x squared minus 9x squared minus 4 times 3 times x squared minus y, and if this is bigger than or equal to 0, we know there is a solution. So just moving things, so we can take out the brackets here to get minus 12x squared plus 12y, and then move all the x squared to one side, so you get 3x squared being smaller than or equal to 12y, or x squared is smaller than 4y. So all we need to check is if x squared is smaller than or equal to 4y, and then we know that we get an equation for a that we can solve, that has a solution at least in real numbers. So let's just look at each case. So in this case, this case first. Here, x is equal to 91, y is equal to 1. So this is x, which is a plus b. This is y, which is a squared minus ab plus b squared. And obviously 91 squared, which I believe is more than 1,000, is not smaller than or equal to 4. So this case is immediately out. Next case, x is equal to 13, y is equal to 7. Now, you can easily calculate to get that 13 squared is 169, and 7 times 4 is simply 28, and then we get that this equation doesn't work. So 169 is not smaller than or equal to 28. So this case is also out. Next, 7 times 13. X is 7 and y is 13. This time our equation does work because we get x is equal to 7, so x squared is 49, and y is equal to 13, so 4y is 52. And indeed, 49 is smaller than 52. So this does work, but we still have to check if this equation will give us whole numbers. But then in our last case, x is equal to 1, y is equal to 91, and of course 1 is smaller than or equal to 4 times 91, so this case also checks out. So now let's look at both of these cases separately and see which results they give. So for the first case that works, so x is equal to 7, y is equal to 13, we'll simply plug it into our equation that we got here. So 3 squared minus 21a plus 49 minus 13 is 36. So this is plus 36. This is equal to 0. So we can divide by 3. So a squared minus 7a plus 12 is equal to 0. And if you squint your eyes a bit, you can see that this can factor out to a minus 3 multiplied by a minus 4. This is equal to 0. So now we have two cases. A is equal to 3, in which case, when you plug that in, you get, unsurprisingly, b is equal to 4. And if you get that, and if you plug in a is equal to 4, unsurprisingly, we'll get that b is equal to 3. So if a is equal to 4, b is equal to 3. And this is our first pair of solutions. And now for our second case, x is equal to 1, y is equal to 91, we'll just we'll just plug it into our equation. So 3a squared minus 3a, and then this time we'll get plus 1 minus 91, so this is minus 90. And that's equal to 0. So now we'll divide by 3 again. A squared minus a minus 30 is equal to 0. And again, if you look at it closely, you can see that this factors out to a. This factors out to a minus 6 multiplied by a plus 5. That's equal to 0, meaning that we have two cases. Either a is equal to 6, which in that case, we plug that in. Unsurprisingly, we'll get b is equal to negative 5. And if in our second case, where a is equal to negative 5, plug that in. Unsurprisingly, we'll get that b is equal to 6. And this is our second pair of solutions. So, all in all, we have 4 solutions. And so, our final answer, which I will write over here, is that our pair AB is one of these 4 pairs. So it's either 3, 4, 4, 3, 6, negative 5, or negative 5, 6. And these are all our solutions that we can get. And finally, that's it. And if you want more content like this, please subscribe to my channel. I'll be uploading more content like this and other interesting topics in the future. And finally, that's it.